Okay, I think it's 9 o'clock, so let's start on time. So good morning to everyone, and welcome to our first edition of the Dust Talks in English language. My name is Patrick Danielson. I'm the CEO of Emicontrols, and together with my colleagues Francesco and Alverman, today I will guide you through these 20 minutes of very concentrated information about dust and dust management. These Dust Talks, they should be a regular event that we will hold every couple of months. And it is normally organized as a short keynote speech about a topic around dust that should provide some inputs to you as our partners, and where we'll share some new information about our company, about our products, but also about dust and dust management in general. Today, the main topic of the Dust Talks will be Francesco's keynote speech, where he will be sharing some information about the recent academic research that we've conducted together with an external partner, and where we research basically the principles about dust abatement and the scientific principles that stand behind it. And then Francesco will also share maybe some just very short insights about some recent tests that we've conducted on our dust abatement equipment. At the end of today's event, Alverman will share some exciting news about our company and also about the upcoming participation of Emicontrols at the Bauma. And just a short couple of organizational notes. Number one is we will record today's meeting. And after the meeting, we will share the link to you, so you can also share this information with your colleagues and your teams. And obviously, we will also send to you the PowerPoint presentation, so you have all the content available. And your questions, I kindly ask, if you have questions or comments, you can send them inside the Teams chat. And then at the end of today's presentation, we reserved a couple of minutes where we can discuss these questions and comments, and then basically provide some further information. So without further ado, I would like to hand over to Francesco and to today's keynote speech about the science behind Emicontrols, what influences the efficiency of water mist-based dust suppression systems.
So thank you, Patrick. So actually today it's a quite exciting topic. Okay, so we're talking about also almost scaring. So the science behind Emicontrols. But in fact, we are talking about mainly the physics. So the physical phenomenon that is behind the dust abatement. So please allow me to be a little bit technical today, because again, we are talking about physics. I will not share with you formulas. I tried to do my best to represent that using graphical representations and charts, but it will be a little bit of technical. So first of all, what is the scope of this presentation, but also of our activity that we are currently doing? You know, Patrick introduced to you already in previous dust talks and in general meetings that we want to move from manufacturer of dust binding machines to a dust expert. So in order to be dust expert, there are some basics we need to know. So we need to know how dust abatement works and what influences that dust abatement. And to do that, we can do two ways. Okay, either we do our own research, and this is for sure something we have to do. But before doing that, it makes sense to start having a look at literature. So there is already so much in literature, so much people have been researching and proving about dust that it's worth having a look at it. And so this is what we are going to see today. So what is already known today in literature about dust? We did that with the help of the university, a university in Austria, that's the Montanuniversität Leoben. There are actually two universities in Europe that are quite well. They did quite some work about dust. So this is one of the two, and the other one is in Germany, in North Rhine-Westphalia. You will see also some content from that other university. So the scope was for us to understand what is true and what is fake. Okay, very often we see some statements about dust, or we see some graphs and so on, and we don't know, just because they are on the internet. We are not sure are they true or not. So we wanted really to go to the source of that and understand who has been working on that, who has been proving those statements. For example, I remember a couple of years ago, I had one slide about firefighting. The first time I presented it, it had an error on it. Then I corrected the error. But I discovered then, like 6 months later, that I discovered that translated into Chinese, into a manufacturer's website that I didn't even know. So actually, just because you find some statements on the internet, it doesn't mean that they are true. Okay, so that is about the scope. So, for example, some statements that we find on the internet. Okay, for example, the smaller the droplets, the better the dust binding. Is that true? We don't know. Okay, we want to understand who stated that. Or another example, the water droplets shall have approximately the same size as the dust particles for the system to work best. Is that true? Who knows? Another example, wood dust is easier to bind than coal dust. Okay, this is something I heard in the last couple of years. Or another statement, the more water you spray, the better you can clean the air from dust. Another one about surfactants. Okay, so the manufacturers of surfactants, they say use our product so you improve your dust efficiency. Is that true again? Okay, so these are the kind of things we wanted to understand. Okay, so since we are talking about science and scientific papers, an important thing when you make a study is to have reproducible conditions. So you want to be able to control as many parameters as possible. And what you see here is it's just an example, okay? But this is an example of what a university or somebody doing research is using to understand the behavior of dust abatement. So that means we have here this kind of tunnel, okay? So we have some air entering and some dust entering into the tunnel. So here you can control the wind speed, you can control the type of dust, you can control the concentration of dust. Then there are some sprinklers here, okay? Sorry, some nozzles here. So these are producing the water mist. You can control the amount of water mist, you can control the droplet size. You really have a total control of all your parameters. And this is what you need when you make some scientific work. Of course, this is not the way that we find in reality with our dust binding turbines. But these are some specific testing conditions, and they are reproducible. So this is just to give an idea what is used, okay? And then to measure the dust concentration, that's at the exit after dust abatement. They typically use some laser scattering system. So this is also something we will be using in our commercial sensors. That means there is a laser source and a sink. So there is a laser. And if there is no dust, there is no interference with the laser. If there are some dust particles hitting or going through the laser, they will be reflected, and a photon detector will measure the reflection. And so we are able to estimate the size of the droplets and of the particles and the quantity and so on. So this is how the system works. Of course, it's very costly. And you see here, there is an example of this equipment. So it's very costly equipment. There are people, it's not something you can just set up for 1 week, you know. There are people that really have been spending years in studying this dust. So again, it's worth having a look at it and see what they found out. So first thing is definition. Okay, it's important to talk about same language. So what do we mean with dust binding or dust abatement? This is when a dust particle gets in touch with some water droplet, with some water, and so the two bind together, and because there is an increase of mass, they go down to ground because of gravity. Okay, so this is abatement. Dust particle and water droplet for some reason hitting together and increasing its mass. This is what we are talking about when we are talking about dust abatement. What type of dust or what type of particles exist? There are a lot of different particles. Okay, so there is, for example, smoke. There is sand. There is fumes. There is really a quite wide variety of particles. But the one we care about are typically these ones. So coal dust. It doesn't have to be coal, okay? But this is what we are caring about. We don't care about fumes or smaller particles. Okay, we care about these ones because these are the ones that are generating problem for the environment and for the health, and because these are the ones that we typically find in our customers and also concrete factories. So these are the most relevant one for us. And also you see they are in between, let's say, a couple of micron and maximal 100 micron. So the point is that if they are, the bigger they are, these dust particles, the less important is the problem, because they tend to fall down by gravity. Okay, 100 micron particle falls down within 5 seconds from 1.5 meter. But the smaller they are, the longer they stay in the air, and then they can do kilometers and kilometers before falling down if they are not abated and captured before. Okay, so this is about definition. Now we are gonna see what influences the behavior of dust abatement. So there are several parameters that influence that. An important information we have to know as dust expert is the so-called greenfield gap. Okay, so what is the greenfield gap? The greenfield gap tells that there are some particles, some size of particles that we just cannot lay down. Okay, so it just physically doesn't work. And these are the particles around 1 micron. Okay, the 1 micron particles, these are several studies that have been proving that. If you want to see then the literature references, we can send you them. But these are just 2 different studies, but they say the same. They demonstrate the same. The 1 micron particles cannot be laid down. If we go bigger, okay, the 5 micron, 10 micron, it works. If we go smaller, it works too. Okay, there are 2 different physical behaviors. But the 1 micron, this is just the size where you cannot lay them down with any type of binding. So this, on the other hand, is not so relevant for us because all dust generated mechanically by crushers or so on is bigger than 1 micron. Okay, so 1 micron is typically pollution and so on. So still, it's a problem for our health. okay, but it doesn't work with dust abatement. Okay, we have to put some filters like in industry and so on. So we cannot abate that with water. Okay, so this is an important concept to know. This is also again another study. It's quite nice to see, I think. So you see here some PM10 particles, PM2.5 particles, and PM1, and they alternate water mist off, water mist on, water mist off, water mist on, and so on. And you see how the concentration of PM10 goes up without water mist, and down with water mist, and up and down and up and down. The same happens with PM2.5, but PM1, no change. Okay. Again, it's a demonstration that PM1 particles, it just doesn't work. So how does it physically work? How does the impaction work? So actually, we're supposed to have a droplet, and we're supposed to have some dust particles. Okay, these are the black ones, and there must be an impaction. So it's important that one has to impact with the other in order to have the capture, the abatement to happen. If the droplets are too big, so what happens is that the dust particles, they tend to surround the droplet, and there is no impaction or interception. Vice versa, if they are too small, then the dust particles get a too little mass increasal, or they get carried away by the airstream. Okay, so there is an optimum of droplet size in order to have the best efficiency. And this has also been proven. This is from the Bergische Universität Wuppertal. So you see here, this is the reduction in percentage of dust, of PM10 dust, so 10 micron, and 2.5 dust, with different sizes of droplets. And you see they have been proving in their case that the best abatement happened with droplets of 140 micron. So this is again for their specific condition, for their testing condition. It's not valid true at all. It's not true generally speaking, but they have been proving that this is true. Another important thing is the dependency on relative speed. As I said before, there has to be an impaction. So there must be a speed difference. There must be a relative speed between the dust, okay, here, and the droplet. If both go into the same direction, they will not impact together. Okay, so there will be a poor dust binding. If they go in different speeds, okay, for example, the dust in this direction here and the droplet in this direction, so the relative speed is high, and the probability of impacting is higher. So there's a good dust abatement. So this is an important thing. I think we observed it already in also with our dust binding machines. I remember Johannes also one day told me about he has been experimenting that, but that's really what physics says. So there must be an impaction and therefore a speed difference between the two. Then another parameter is the water flow. So how much water do you need? Is it true that the more water, the better result? Yes, it is true. Okay, so in fact, the more water you use, the better you get the efficiency of your system. But it's, let's say, logarithmic. Okay, so what does it mean? It means at the beginning, you have a big improvement with little water. But the more water you employ, the less you have then your improvement. Okay, so your maximal improvement, you have it using a little bit of water. If you then use 10 times of water, you don't have 10 times better results. You have just double better results. Okay, so again, this has been proven This is not just theory, okay? This has been observed in reality. Then another point are the surfactants, okay? So is it true that surfactants improve the dust abatement? So if we look what surfactants are and what they do, we see that surfactants are reducing the surface tension of the droplets. Okay, so they make it easier for the droplets to break, and it makes it easier to generate small droplets. But smaller droplets are not always better droplets. Okay, so it depends. If we have low pressure, big nozzles, and we are not able to generate the right size of droplets, some surfactants may help to lead us to the right size. But if our droplets are already the right size and we use surfactants, we make smaller droplets, we have a worse result. Okay, so it's not true that surfactants are better at all. It depends on the droplet size I'm starting from. Okay, so I resume. We have been seeing the difference of efficiency of dust binding systems depending on the size of the dust particles. So green field effect. Droplet size, the relative speed, very important. The amount of water flow and the surfactants. There are some other parameters, but I will not go into these ones, like air temperature, air pressure, air humidity. For example, if you have very hot temperatures, then the boundary of your spray will evaporate, okay? But it becomes too complex and we have no time, okay, to go through that. So these are additional parameters. So you see, it's quite a complex scenario, but these are the actors. These are the parameters. And also, all we saw until now was about impaction or interception. Okay, so this is one type of interaction. And this is the most relevant for us because it concerns the droplets bigger than 1 micron or 2.5 microns. There are some other phenomena that happen for very small droplets, like condensation, diffusion, and electrostatic forces. So we don't really care about those because they happen for very small particles. Nevertheless, just for the sake of being complete, I just tell you what it means. Okay, so condensation, that happens for particles smaller than 1 micron, and it happens when the atmosphere is saturated and near to the dew point. Okay, so what happens is that those small particles, they act as condensation nuclei. And so the mass grows because the humidity is condensing around this nuclei, and the gravity makes it fall to ground. But again, this is relevant in meteorology or also for snowmaking. This is one principle behind, but we don't care about that for our customers, for our sites. Condensation. So next one, diffusion. What's diffusion? That's again for very small particles. So less than 0.001 micron, so 1 nanometer. And these particles, they just have random behaviors, okay? And it can happen that through these random behaviors, they hit some water molecules. But here we are talking about molecules, okay? So you see, I hope the video, these are from poles, the ones generating allergy. So we are here really in the size of big molecules. So again, this just for you to know, but it's not relevant for our scope. And finally, electrostatic forces. This is interesting, could be interesting. So if we have droplets that are positively charged and dust that is negatively charged, or vice versa, the dust abatement may be improved because there is an electrostatic attraction between the two. So in fact, there are some studies, even with dust abatement turbines, that have been started on that topic. One in Japan and one in Germany. But honestly, I'm still waiting for some results. I never saw some results. So I guess it's very complicated because you don't know if your dust is charged positively or negatively. So I think it's difficult to drive. Okay, so that was about the different type of interactions. Okay, so this is what we saw is the science, okay, about particles in experimental conditions. Next question is, how does all that apply to our dust binding turbines? So how should I put it? Let's say there are good and bad news. The bad news is we don't know. We don't know because there are so many parameters that you have to consider outside, okay? And today we don't know. But the good news are nobody knows. Okay, there are no studies today. And the good things also is that we are investigating that. We are already started doing quite some effort to understand how we can apply all this theory to our dust binding machines. For example, we know our droplet size. Okay, that's an important thing to start from. Okay, so this is something we did some years ago, but okay, it was V7. Actually, it was DCT5, old version. But okay, you know, we went through the laser principle I showed you before. Okay, and the measuring, and so we know our droplet distribution. Okay, we know we are around 200 and 300 micron, depending on the nozzles. We can go a little bit less, we can go a little bit up, but we know that. Okay, so that's one important thing. And also, we made some work we made last year. We studied the distribution, the footprint of our turbines, of all our turbines. Okay, this is just an example for the V22. We see according to the distance, spray distance of the machine, how much water, what's the density of droplets. So we see we reach 90 meters with this distribution. Okay, and this is what you see at 90 meters distance happening. And yeah, this is also part of the study we did last year. Okay, we know exactly the footprint. We try to describe it as exact as possible. And if you are interested in that, just go to the EMI Controls website, member area, inscribe, make your inscription to the member area, and you will get the password to access to that information. And my last slide, we are going on testing. Okay, so we already selected, I think now there are 4 sensors here, but actually we are selected 6 sensors. We started studying the behavior of the sensors, the interference with water mist of the sensors. We made the comparison to reference sensors, to very costly reference sensors. So we are selecting the one that work best for our purpose and the one that work best to integrate them into our system in order to make our system more intelligent. And here there's still a lot of work to do, but we are working on it, and we will be working on it also in the next weeks and months. And I hope we will be able to be back soon to you with some new information about the efficiency and the dust abatement behavior of our turbines. So that's all from my side. Thank you, and I give the stage back to Patrick.
Actually, I'll hand right over to Alvaman, who is going to share some updates on the upcoming events.
Okay, good morning, everybody. Good afternoon for someone. We are today talking to an audience of listeners that represents a good part of the world. And since we are talking about the world, especially today, the world that makes dust, quarries, mines, and demolition, we want to inform you that in 10 days from today, the Bauma exhibition will be finally start in Munich. It was supposed to be last year on 2021, but due to the pandemic situation, it was moved to 2022. Usually the Bauma is in spring, but it was too close to the IFAT show, so they decided to move in October. As you know, the Bauma is the most important exhibition together with the ConExpo in Las Vegas for both concern the heavy equipment and heavy machinery. And the whole world that is together with them. I mean, from the supplier for the construction of the heavy equipment and all the various sector of application. So the quarry, mines, demolition, construction. So it's our world, let me say. We invite you to join us and to visit our booth. You personally, also with your customer, with your end user, and we, as you can see from the slide, we present, of course, the machines, but not only the equipment that we have. The most important part this year will be the interconnections that we have with our machines, with the turbine, with the H2 family, with the sensor, with the weather station, with maybe also external signal from the client. And all together is managed by our conductor, a Kurt software that we started to develop some years ago. And now we are implementing several applications, and now we want to show to our world what we are doing with our software. And the next slide. And we want to inform you that we have a new office, a new branch, EMI Controls Europe, a new reality that will be based in Germany, close to Frankfurt. Is the first branch that we open. And this company will be present and will be officially launched on the market, and will be present with the second booth on the outdoor area of the Bauma show. Again, also here you will have the possibility to talk with our colleagues that are taking care about the German and Austrian market. We present our equipment, the machines, the H2 family, but also in this booth we have the conductor, the Kurt software with weather station, and will be very, very interesting to explain to you, but also to your customer, to all the people that will visit us, the way that EMI Controls is going in the future, just to be more efficient, especially from the water consumption, power consumption point of view, maintaining a very, very high efficiency in the dust abatement. So finally, after some years that we were waiting to have the possibility to show what we are doing to all the world of dust, finally, in 10 days, we are there, and you are more than welcome.
Thank you, Alman, for this good news. And I saw there is one question in the chat posed by Ville. Maybe Francesco, if you want to follow up on that.
Yeah, maybe Ville, maybe if you want to repeat that.
It's about everybody. The droplet spectrum of that test, because you mentioned 140 microns. So was it like a DV09, meaning 90% of droplets is on with that dimension, or?
No, it's DV50. So
okay,
actually,
perfect.
It's based on just short explanation. So the droplet size, as you have seen on this slide, for example, it's not just one value. Okay, you don't have, when you spray some droplets, you don't have just droplets of 100 micron or 200.
No. It was just about that question, meaning 90%.
Explain it for everybody. Okay, so you have a distribution. Okay, so how can you describe this distribution with one parameter? One of the most used ones is the DV50 value. The DV50 is the median value of this distribution. That means that's the value where you have 50% of your droplets. For example, in this case, let's suppose, I don't know, it is 260 maybe, okay? So that means 50% of your droplets are before and 50% are after, okay? So on this slide here, on this slide, they use the DV50 parameter. That's the most used one.
Mm-hmm. Okay, thank you, Francesco, for the clarification and explanation. There are no other questions inside the comments section. I think also, as we are a little bit over time, I would like to conclude the meeting. And then if someone of you has any further questions or comments, obviously you can reach out to us, either to your sales responsible salesperson, but also directly to Francesco, Alverman, or me. And also, if you have some suggestions about the format of this event, if you have any suggestions about topics which would interest you, please send us some info and feedback. We very much appreciate that. As I mentioned, we will hold the next meeting in a couple of months. We will always try to keep some news about our industry that will increase your knowledge and maybe give you some inputs on how to further develop your business. And yeah, with that, I think we can conclude today's meeting. I would like to thank all of you for your attention and participation, your interest in our seminar. And with that, I hope to see all of you at the Bauma in 2 weeks. And I wish you a good start into your Friday and maybe an early start into the weekend. Thank you very much.
Thanks a lot. Bye-bye.
Bye-bye.
Bye. 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 Bye, everybody.
Bye. Bye.
Thanks. Bye.